Welcome to your deep dive. We're tackling the butterfly effect today,
Nice.
but not the Hollywood version. You really wanted to dig into the history and the actual science.
Right.
And you sent over some really cool excerpts, by the way, from the Wikipedia article on it. So
Yeah.
that's going to be our starting point.
It's deceptively simple when you first hear it. You know what I mean?
Yeah.
Like the butterfly effect. But then you start getting into it and it's like, whoa, there's some depth here.
Yeah, for sure. Most people know that saying, right? A butterfly flaps its wings and then boom, tornado across the world. But something tells me there's got to be more to it.
Yeah. That's more how do I put it, the elevator pitch version, like sensitive dependence on initial conditions, how these tiny, tiny changes can spiral out in ways you could never predict, especially in systems with lots of moving parts.
Makes sense.
But like a
Yeah.
butterfly actually causing a tornado, that's more like a metaphor to help us wrap our heads around it.
So not literal then?
Not really, no. But what is wild is how far back this idea goes, way before Edward Lorenz coined butterfly effect back in the 70s.
Wait, hold on. Lorenz wasn't the first one on this.
Nope.
Okay, now you've got me hooked. Who else was in on this whole idea?
Well, you've got those excerpts from Johann Gottlieb Fichte. Now, he was a philosopher back in the 1800s,
Okay.
and he was writing about how you couldn't even move a single grain of sand without, like, changing the entire universe somehow.
Whoa. That's some next level interconnectedness right there. To think people were considering this stuff back then?
It really is. And get this, Fichte wasn't alone. Fast forward about 90 years, you've got Henri Poincaré, a brilliant mathematician,
Okay.
and he's wrestling with this thing called the three-body problem.
Three-body. That sounds kind of complicated.
It is. It totally is. Basically, imagine three celestial bodies, like planets, all orbiting each other.
Okay, I'm picturing it.
The question is, can you perfectly predict their movements? And what Poincaré found was, even the tiniest error in your starting measurements, like where each planet is at the very beginning, those errors would just multiply like crazy over time, making any long-term prediction impossible.
So even in the supposedly predictable dance of the cosmos, there's chaos lurking. Makes you wonder if anything can truly be predicted,
Exactly. And this idea, it kept popping up in other fields too. Alan Turing, the father of computer science, AI, all that, he had this observation in 1950. It's kind of eerie, actually. He wrote about how the smallest thing, like an electron being just slightly off, could be the difference between, say, someone getting hit by an avalanche a year later or totally escaping it.
Wow, now that's an image. It's amazing how this idea was brewing in such different areas. Philosophy, math, physics, almost like everyone was tapping into this fundamental truth about how interconnected everything is, even before we had the scientific language for it.
And speaking of being ahead of the curve,
Yeah.
we got to talk about Ray Bradbury.
Oh, right. The science fiction author. Are you talking about his story, A Sound of Thunder? Because I remember that something about time travel and a butterfly.
Yes. And here's the mind-blowing part. He published that back in '52, before Lorenz even did his research.
No way.
Yep. It's about these time travelers, and they accidentally kill a butterfly during a hunting trip back in prehistoric times.
And that tiny action ripples through time and changes the future, right?
Exactly. They get back, and the world's totally different, all because of this one butterfly. But it gets even weirder. There's this children's book, The Phantom Toll Booth from 1962, and get this, there's a line in it. Whatever we do affects everything and everyone else, if even in the tiniest way. Why, when housefly flaps his wings, a breeze goes around the world.
Wait, are you telling me a children's book basically predicted this whole scientific concept? That's crazy.
It really makes you think, right? It's like these ideas, they're out there in the culture, even before science can fully explain them. Like this intuitive understanding of how things work, just waiting for the right words to catch up.
So we've got philosophers, mathematicians, computer scientists, even children's books, all kind of circling this idea.
Right.
But then how does Lorenz come in with the actual, scientific proof? You were saying he was doing weather simulations.
Yep. Back in 1961, he's running these simulations on, a super early computer trying to predict weather patterns.
Okay.
He'd run one simulation and he wanted to basically rerun it
Right.
to double check,
Makes sense.
But instead of typing in the full precise numbers from the first run, all those decimals for temperature, wind speed, you name it, he rounded them off.
Makes sense. Who needs all those extra digits, right?
Yeah.
Especially back then, computers were.
Exactly. He figured, a tiny rounding error won't change the outcome that much.
Yeah.
Boy, was he in for a surprise.
What happened?
So instead of the simulation playing out basically the same, this tiny change, just from rounding those numbers, it spiraled. Like completely different weather predictions.
Get out! Seriously!
Oh, yeah. We're talking a rounding error so small you'd barely think twice about it, leading to, like, massive storms showing up in the new model.
So, a happy accident, basically. He must have been floored. Did he write about that moment?
He did. There's this great line in his book, The Essence of Chaos. He's describing how the difference between the two simulations just kept growing.
Oh, man.
And I got to quote this because it's just perfect. All resemblance with the original output disappeared somewhere in the second month. This was enough to tell me what had happened. The numbers that I had typed in were not the exact original numbers, but were the rounded off values.
So, boom, he stumbles onto this huge discovery about how these tiny, tiny things can snowball.
But didn't you say he didn't even use the butterfly thing at first? It was a seagull?
True story. Originally, he was writing about a seagull flapping its wings and causing, like, a big storm.
Interesting.
But then in 72, he's prepping for a lecture, and he switches it up to a butterfly. I wonder what sparked that change. Maybe butterflies are just more, I don't know, poetic than seagulls. But whatever the reason, it definitely stuck.
Yeah.
You also mentioned, though, that scientifically a butterfly probably can't actually whip up a tornado, right? What's the research say about that?
Yeah, so recent studies, they're suggesting that a single butterfly, even with chaos theory and all, just doesn't have the energy to impact weather systems on like a global scale.
Okay, so we can debunk that part of the myth, I guess. Does that mean the whole butterfly effect idea falls apart then?
Not at all. The key is that all models, even the super fancy weather models we have now, they're still simplified versions of reality, right?
Yeah.
There's always going to be some degree of model error.
Sure.
And in any complex system like the atmosphere, those tiny errors, those discrepancies we can't perfectly account for, that's where things can get unpredictable with big consequences.
Makes you realize how much we just assume will be predictable when actually
Yeah.
it's not that simple. So if it's not all about weather, then where else does this butterfly effect show up?
That's the fun part. You were really curious about the bigger picture
Yeah,
because this goes way beyond just forecasting the weather.
totally. Like, what about the quantum world? Does the butterfly effect work down there?
Now that's a question that's got even physicists debating. Like even at that subatomic level where things get really weird, really counterintuitive, there's still this discussion of, does the butterfly effect even apply there? Makes you wonder if there are limits to this idea, or if it's just fundamentally baked into how reality works at every level.
Okay, now you're blowing my mind. You also mentioned history and just like society in general, right?
Like, think about it. What if some seemingly small decision, someone taking a different route home, whatever,
Yeah.
what if that sets off this chain of events that changes the course of, like, world history?
Wow.
Right. It's a lot to process.
It really is. Makes you think about all those what ifs throughout history and how something so small could rippled out in ways we can't even imagine. It's almost like you feel incredibly small, but then also like kind of powerful at the same time, you know?
Right.
Because we're all part of this web.
That's such a good way to put it. It's like that's what makes the butterfly effect so mind-blowing. It's not about like predicting the future perfectly. It's more about just realizing, wow, everything's connected and we can't always grasp how our actions are going to play out.
So maybe it's a lesson in humility more than anything.
Totally. Admitting we're not in control as much as we think, but at the same time, even the tiniest choices we make, they can ripple out in ways we'd never imagine.
It's kind of freeing in a way, right? Like we don't need to be frozen by all the what ifs. Just be thoughtful, aware of the choices we're making and the potential consequences.
Exactly. Recognizing that we're each part of something so much bigger, this web of interactions where even the smallest thing can cause a tremor across the whole system.
Makes you think twice about all those everyday decisions, the ones you make without even thinking. Like, what if that random encounter, that tiny choice you barely remember making, what if that ends up shaping your whole life? Or someone else's life?
It's humbling, for sure.
Yeah.
And kind of exciting. It's like every moment's got this hidden potential, right?
Yeah.
For good or bad.
Mm-hmm.
We can't control the ripples, but we can choose what we put out there.
It makes me think of that quote, I think it's Gandhi, be the change you wish to see in the world. Even if we don't know exactly what the impact will be, at least we can try to act intentionally.
Beautifully said.
Yeah.
And that kind of brings us full circle back to your deep dive here. The butterfly effect, it's about our connection to each other, to the whole world around us. It's about approaching things with a sense of wonder, curiosity, and maybe a little humility too.
Couldn't agree more. And that's your deep dive for today, folks. We went from like grains of sand and seagulls all the way to the edge of chaos theory, uncovering the history and the mind-blowing implications of this butterfly effect. Hold on to those excerpts you sent, and hey, next time you see a butterfly, take a second to think about all those connections it represents. Never know what you might set in motion. Until next time.